In this tutorial, I will share the process of how I created this animation using Cinema 4D and Redshift. By the end of this video, you will be able to achieve the same result. The story begins with airplane modeling. The wings were modeled first, followed by the body. To speed up the process, the power of the symmetry tool was fully utilized. A cylinder and cloner tool were used to create the wing supporters. After the completion of that modeling stage, attention was gradually shifted towards modeling the propeller and its base. The top wing was adjusted to closely match the printed reference image. Using the pen tool, the airplane body mesh was modified by adding a cabin, requiring considerable time to achieve the desired shape that met all of my aesthetic criteria. The cabin was finalized using the sweep tool to create a smooth framing shape. Furthermore, front wheels were incorporated into the model, with slight adjustments made to enhance their realism. A tail was added, consisting of a single extruded polygon that was replicated 3 times. To complete the model, the rear wheel was duplicated from the front one and combined with the low poly rear wheel model support structure. The model is now ready. Make sure your airplane model consists of 2 pieces, one for the propeller and another for the body, both placed inside the null object. Let's build the planet with tentacles. We will start by using a sphere with the object type of icosahedron. Adjust the size of the sphere if necessary. The next step involves adding a moss-spline object to the scene and adjusting its length. Place it inside the cloner object, selecting Object Mode and dragging a sphere object into the object field. Within the cloner object, set the distribution property to vertex. This will ensure that all the cloned splines are located at each vertex of our sphere. Add a connect object and make it a parent of the cloner. Then add a sweep object and make it a parent of the connect object. Inside the sweep object, place a circle and adjust its radius. Increase the size of the caps and the subdivision property of the sweep object. Consolidate all the elements we have added for the planet inside the null object. Create a copy of our sphere and scale it slightly larger than the master sphere. Enable solo mode to hide all unnecessary objects for the moment. Select all the vertex points of the sphere and apply an extrude modifier. Adjust the bevel value to achieve the desired size of the hexagons. Delete the vertices to create a sphere with hexagonal holes. Extrude the surface and apply a subdivision surface modifier to create an external skin for our planet. Turn off solo mode to bring back all the geometry. Duplicate the planet core sphere and scale it slightly larger than the original planet core sphere. Adjust its size if necessary. Add Attractor and Turbulence forces to the scene. For now, turn off the Attractor force and focus on the Turbulence force. Adjust the strands, scale and frequency properties to find the right balance for your scene. If you notice that the animation playback is slow, you can address this issue by simplifying the topology. Decrease the value of the steps property of the most spline object, as well as the number property of the circle object. This will reduce the computational power required to calculate the animation. Experiment with these properties to find the optimal combination. Additionally, you can try decreasing the value of the cap subdivision property of the sweep object. Place the sweep object inside the subdivision surface. This will result in smoother topology of the tentacles. As you can see, the simplification of the topology has had a positive impact on the responsiveness of the viewport animation. Now let's back to the attractor force. In the viewport, position it inside the airplane. In the object panel, select the airplane null object and in the viewport, locate its axis point in the middle of the planet. It's preferable to position it precisely, but it's not crucial. Make any other minor adjustments according to your preferences, if necessary. In the object panel, place an attractor force inside the airplane null. Turn it on and increase the strength property to amplify its impact. Try rotating the airplane null object around the planet. You will notice that the airplane starts attracting the tentacles like a magnet. The next step is to add realistic and more organic movements to the planet and the airplane. Add another null object inside the main airplane null and place your airplane model there, naming it, for example, rotation null. Apply the vibrant tag to the rotation null. Enable the rotation property and adjust the amplitude and frequency values to achieve a realistic movement of the airplane. To finalize the airplane's animation, we will animate the propeller. Set two rotation keyframes at 0 and 360 degrees. In the timeline menu, select your propeller object and set the before and after property values to repeat to loop the animation. Also, select the rotation keyframes and set the speed to linear. These settings will enable us to rotate the propeller endlessly with a consistent speed. For the circular movement animation of the airplane, use the top airplane null and apply the same technique we used for the propeller animation. That's the current state of the animation result. Add a vibrant tag to the planet null. Enable the rotation property and experiment with the amplitude and frequency settings to achieve an organic rotation. Now it's time to add an airplane smoke trail to the scene. Place a cube inside the top of the airplane null, ensuring it is small enough to be hidden within the airplane model. Add a pyro emitter tag to the cube and adjust the settings of the automatically appeared pyro output object as shown. Add a Redshift pyro volume material and apply it to the pyro output object. You will now see smoke appearing in the viewport. Next, let's focus on texturing and lighting. All materials used in this tutorial are free materials, available within Cinema 4D, except for the simple emissive material with an emissive red channel. To prevent any accidental camera movements, add a protection tag to the Redshift camera. If your scene appears a bit dark, let's address this issue by adding a few area lights. Experiment with the size, color and position to achieve the desired lighting effect. In the Redshift render view, enable the bloom effect and adjust the emissive weight level of your light sources. Finally, turn on the streak effect in the Redshift render view. Check the overall composition of your scene. Set the focus distance and aperture of your Redshift camera and turn on the bokeh effect. Cache your pyro smoke simulation and click the render button. If you reach the end of the video, you should be able to achieve the same animation result as I did. See you all next time!